Hello and welcome to Mr. Connect's virtual classroom. Today we're going to be talking about finding the area of circles and sectors. And to help me is quite a round friend. Many know him as BB-8, and he's with me today because tomorrow is Star Wars Day. So I want to wish you a happy Star Wars Day, and we will get into our lesson on the area of circles and sectors. To start off our discussion today on the area of circles, we're first going to review the formula for finding the area of a circle. And that's given by the formula area equals pi times radius squared. Okay? We all know that pi is about 3.14, and we know what the radius of the circle is. Okay? So to use this problem, we're going to take a look at the Death Star from Star Wars, because after all, it is around the time of Star Wars Day. So imagine that you're a pilot in an X-Wing, and you're coming up on the Death Star. It's not going to appear as a whole sphere, because you can only see the front of it. So we're going to think of the Death Star here as a circle rather than a sphere, just for the sake of the example. And we know that the diameter of the Death Star is 160 kilometers. To find the area of the shape that we're looking at, we need the radius. So to find the radius, we're going to take the diameter and divide it by 2. So when we divide 160 by 2, we get 80 kilometers. Okay. Now we have everything we need to find the area of the Death Star from our perspective. So area equals pi times radius squared, which equals pi times 80 kilometers squared, which gives us 6,400 pi kilometers squared. Or when we approximate that, gives us about 20,106 square kilometers. So it's no wonder that Obi-Wan confused the Death Star for a moon. The area, if we were looking at it, of the Death Star is about 20,106 kilometers squared. Now that we know how to find the area of the whole circle, we're now going to look at finding the area of parts of the circle. And so one way that we can break up a circle is we break it up into what's called sectors. And a sector is formed by 2 radii forming a central angle and closed in by an arc of the circle. So to find the area of a sector is very similar to finding an arc length. Now, if you remember to our last lesson, the arc length was figuring out what fraction of the circle's perimeter the arc took up and multiplying that fraction by the perimeter of the entire circle. Finding the area of the sector is very similar to that. We find what fraction of our circle, remember, the measure of our angle of our arc over 360, representing the whole circle, and multiplying by the area of the circle, pi r squared. So similar process. Find what fraction of the circle you're looking at, multiply by the area to find the area of a sector. Okay, so let's use this idea of finding the area of a sector. Here we're given the sector of a circle P. And this sector is defined by an arc of 72 degrees. And the circle has a radius of 15 centimeters. So we have everything we need to find the area of the sector. So we have everything we need to find the area of sector PGH. So let's write it out. Area of PGH equals the measure of arc GH over 360 times the area of our circle, which is pi times radius squared. Okay, so let's plug in what we have. We know that the measure of arc GH is 72 degrees. So 72 over 360 times pi times our radius, which is 15 centimeters squared. So when we simplify 72 over 360, that simplifies to 1 over 5. And then 15 squared becomes 225 square centimeters. Okay? So 1/5, to simplify this, we're going to multiply 1/5 times 225. And if you work that out, it'll 1/5 times 225 is 45. So the area of sector PGH is 45 pi centimeters squared. And most of the time you'll want to leave your answer in terms of pi. We found the fraction of the circle we were looking at and multiplied that fraction times the area of the circle to find what fraction of the circle's area the sector was taking up. So sometimes we're asked to find the area of parts of a circle that are not sectors. Take this shaded region for instance. This is not a sector of the circle. We call this a segment of a circle. And all a segment is the area that is enclosed by the edge of the circle and a line between the endpoints of two radii on the circle. Okay, so how do we find the area of these segments? Well, think of it kind of like taking one chunk out of a sector, right? So we could find the area of the sector So think of finding the area of a segment like finding the area. So think of finding the area of a segment like finding the area of a part. So think of finding the area of a segment like taking a chunk out of a sector, right? So to find the area of a segment, the area of a segment we're going to take the area of this whole sector and we're going to subtract this part of the sector that we don't want to include. And what shape is that? That's a triangle. So for our purposes, we're just going to refer to this as the triangle. So the area of the segment is equal to the area of the sector minus the area of the triangle. Okay, so we take out the part of the area that the part of the area of the sector that we don't want in order to find the area of our segment. Okay, we're going to go with another corny Star Wars example, but then again, it is Star Wars Day. So we're going to pretend that this is the second Death Star, which in Return of the Jedi is still under construction. So the Empire was like, we really like the Death Star, but Luke Skywalker blew it up about 6 years ago. We need a new one, right? And so we're going to try to find how much of, okay, normally this would be volume, but because we're looking at it straight on, we're gonna just find the area of the shape that we're looking at. We're going to find the area of this section of the Death Star that is still that still needs to be constructed, right? And we have a radius of 80 degrees, a radius of 80 kilometers, and a central angle, and thus a minor arc of 60 degrees. So to find the area of the segment, we first need to find the area of the sector, the area of the triangle. So let's find the area of the sector real quick, right? So let's just call this D, we'll call this arc DS, right? So we need the measure of DS over 360 times pi r squared times the area of the Death Star. Okay, we get 60 over 360 times pi times 80 squared. And thus we're left with 1/6 times pi times 6,400 square kilometers. So when we simplify that fraction, 1/6 times 6,400, we get about 1,066.67 times pi kilometers squared. Okay, now we have the area of this whole sector. We'll call this the center W. So the DSW or DWS has an area of 1,066.67 pi square kilometers. But now we need to find the area of this triangle. And now we're going to jump back. To do that, we're going to jump back a couple lessons ago since we don't know the height of this triangle, but we do know the lengths of two sides and the angle included between them, we can use the formula that we generated 2 lessons ago to find the area of this triangle. Right? So now that we have the area of our sector, we need to find the area of the triangle that's included within that sector. Okay. So to help us with that, I brought the triangle out over here, right? And so we're going to draw an altitude from our central angle to our opposite side. Now remember, when we do that, we bisect our central angle so that this inside angle is now 30 degrees. And the altitude bisects our opposite side so that this side here is 40 kilometers. Okay. And we can figure out that this half of the side of this triangle will be 40 kilometers because we know that this is an equilateral triangle because this angle is 60, this angle is 60, and this angle is 60. So we know that all three sides have to be 80. So half of 80 is 40 kilometers. In most of your problems, you will probably have to figure out using trigonometry what the length of this side or both halves of these sides are. Now we're going to use the formula that we came up with 2 lessons ago to find the area of a triangle that we don't know the height. See, here we have 2 sides, and then we can use deductive reasoning to find that we have an angle of 60 degrees in between our 2 sides. So using the formula we came up with, the area of this triangle is 1/2 times one of our sides times the other half, or the other side, excuse me, times the sine of the angle in between them. So when we work this out, we get, we'll cancel that out. We get 40 times 40, which is 1,600. And we know that sine of 60 degrees is the square root of 3 from our special right triangle relationships. And so we know that the area of our triangle here is 1,600 times the square root of 3 square kilometers. So now that we have the area of our sector and the area of our triangle, we can find the area of our segment by simply taking the area of the whole sector and subtracting out the area of this triangle. So we're going to take 1,066.67 pi, and we're going to subtract 1,600 times square root of 3. Okay. And when we subtract that out, we get about 579.75 square kilometers. Okay. 579.75 square kilometers. So that's how much work. So this is how much the Empire has to build, still working on their Death Star. They still have, if you're looking at it in a 2D kind of way, they still have 579.75 square kilometers to build. I hope that you enjoyed our discussion of the area of circles and sectors. I wanted to leave you guys today with a passage from John chapter 1. It says, "In the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God. All things came to be through him, and without him nothing came to be. What came to be through him was life, and this life was the light of the human race. The light shines in the darkness, and the darkness has not overcome it. As I think about, Star Wars and literally this battle of the light side versus the dark side, you always know that the light side is going to win. And here it says that the light of God is the life of God that God gives is the light of the human race. And so know that whatever struggle you're going through, when you put it into God's hands, He can help you through it, and the light will overcome the dark. So I hope that you and your family have a blessed day, and may the force be with you.